Okay, in this video, we're going to just do like a crash course with some Algebra 1 review that you will need in order to do our 4.4 notes. So first thing we want to know is everything in this box. This is just saying that we can go from radicals, things that look like square root symbols, but they could be cube roots or fourth roots, to rational exponents, exponents that are fractions, okay? They can look either like this first diagram or this second one. So for questions 1 through 8, we're just going to go back and forth between the forms. Okay, in question number 1, I have 3 to the 1/2. I can rewrite that in radical form with a radical symbol. 3 is my base, so 3 is going to become the radicand. 2 is the denominator, that's going to become the index, the little number on the ledge, and 1 is going to stay my exponent, okay, the top number 1. Okay, so this really says the square root of 3 to the first, or just the square root of 3. When this number is a 2, you don't necessarily need it here because it's implied to be a square root. For the next one, same idea, we're going to draw our radical symbol. 4 is going to be our radicand, 3 is going to be our index, 2 is going to stay our exponent. So this says the cube root of 4 squared. Okay, we can keep going even if there's variables. This one would be the third root of x to the 5th. This next one would be the 10th root of y to the 3rd. For questions 5 through 8, we're just going the other way. Now we're going to write them with a rational exponent or a fraction exponent. On number 5, I don't see an exponent originally given to me, so I'm going to assume that there's a 1 here, saying that this is 12 to the 1/4. This next one is going to be y to the 2/3. This one is going to be 10 to the 3/2. And this next one is going to be x to the 4/5. Okay, so again, we're just bringing everything back to this diagram, going back and forth between the forms. This is going to be helpful when we are evaluating things with rational exponents, because off the top of my head, for example, I don't know what 9 to the 3/2 equals. But if I rewrite it with a radical, I know that this is asking me to evaluate the square root of 9 cubed. Okay, I know that the square root of 9 is 3, and then if I take that number and cube it, I get 27. Okay, so that's how I'm going to treat the rest of these problems. Instead of 27 to the 2/3, I could say this is the cube root of 27 squared. I know the cube root of 27 is 3, and when I square that number, I get 9. Okay, let's drop our equal sign down all the way. We don't want to lose that. The next one, 16 to the 1/4, is the same as the 4th root of 16 to the 1st. The 4th root of 16, what times itself 4 times is 16 is 2, and 2 to the 1st is still 2. Okay, the next section is asking us to simplify radicals. We've actually done this year. This is where we look at the number underneath the radical and ask ourselves if there are any perfect squares that live inside of it. So for example, I know that 54 is not a perfect square itself. Let me write that better. But there are factors of 54 that are perfect squares. Okay, I know that 54 is the same as 9 times 6. 9 is a perfect square. So I'm going to rewrite this, the square root of 9 times 6, which is the same as the square root of 9 times the square root of 6. And I can take the square root of 9, which is 3, leaving the 6 alone. This is its fully simplified form, 3 square root 6. Okay, with 12, I know that 12 is the same as 4 times 3. I'm choosing 4 and 3 because 4 is a perfect square. The square root of 4 is 2. I'm going to leave the 3 alone. Okay, so 2 square root 3 is my simplified answer there. The square root of 300 I could write as 100 times the square root of 3. The square root of 100 is 10. Not going to take the square root of 3 nicely, so I leave it 10 square root 3. And lastly, the square root of 75 can be rewritten as 25 times 3, where the square root of 25 is 5, and the 3 is going to stay.